All right, so welcome to our introduction of factoring trinomials. And we're going to factor trinomials in the form such that a is equal to 1. And we'll talk about that in just a moment. First, we want to look at what we already know. All right, so if we have two binomials and we need to multiply them out, we need to use our method called FOIL, which is our first, outer, inner, last. So basically what we're doing is we're taking the first term in the first binomial and multiplying it by both terms in the second. That constitutes my first, so I have x times x, which is x squared. And I take that first term, also multiply it by the last term in the second binomial, which is x times 4, which is plus 4x. All right? Then I go ahead and do the second term by the first term in the second binomial, which gives me plus 2x. And then that last term in the first binomial, last term in the second binomial, which is my L, my last. 2 times 4, which is 8. Okay. And then we notice our middle two terms are like terms. We can actually add them together. Remember, we add the numbers and keep the x as it is. So this is 4 plus 2, which is 6, and the x. And then the 8 and the x squared drop down. And we end up with this trinomial number thing. Now what we want to do is we want to take this trinomial, I said number thing, that's funny. We'll take us trinomial, and we want to now take it back the other direction to its two binomials. Okay. Now the first thing we need to look at is our standard form. All right. And our standard trinomial form is ax squared plus bx plus c. Okay, and when we're talking about a equals 1, we're talking about that the term in front of the x squared is going to be 1. So you're not going to see a number in front of the x squared even though there is an implied 1. All right? And so when we factor things like this, what we're really looking at is we're factoring things that's x squared plus bx plus c. Now the signs, we're going to change plus and minus. Right now we're going to stick with totally plus. Okay. And we're going to talk a little bit about the steps, how we're going to make this happen. All right. So as we start, always our first step when we factoring anything is to look for a GCF for all terms. And this is not going to change no matter what kind of factoring we do. So for all the terms, in this case there's 3, we want to look and see if there's a GCF for all those terms. Okay. If there's not a GCF, then the second thing I'm going to do is I'm going to look at my last sign. And this will make more sense when I do one. And that sign is going to tell me if my binomials are going to have the same or different sign. So we're looking at that last sign, that third sign. We want to see if my signs are going to be the same or different. Okay. The third thing I want to do is I want to look at the first sign. And again, it's going to tell me information of what type of signs I'm looking at. And it'll make a difference whether my last sign is same or different. But I want to know what my signs are that I'm going to be dealing with in my binomials. Right? Then I want to go ahead, I want to look at factors of my C. Okay. And I want to look at factors of C such they either add or subtract, depending on what I have, to B. Okay. And this is slightly different when A is not equal to 1. We're going to talk about that when we get there. So for right now, we're just looking for factors of C that either add or subtract. and give me b. Then we set up our binomials. With our variables, usually x, but they are different. Okay, and then we place our numbers. Now this is what something as I refer to, I don't know what it is called, is the necklace method. The necklace isn't as apparent when a is equal to 1, but it's a very useful when a is not equal to 1. There are multiple ways to go ahead and factor. Common one is the AC method. The AC method gets really big numbers, and seeing as we are not using a calculator, we don't have the option to play around with numbers on a calculator to see if we could figure out what a large number would break down into. So I'm going to use this method, but you are of course welcome to use any method. You have learned previously the box method, guess and check, whatever you would like to use. I'm going to stick with the necklace method. I would like you to at least try it and see what you think about it without the use of a calculator. All right. So now what we want to do is we went ahead and multiplied, and we got this trinomial. And now I want to factor this. And I want to factor this, I'm going to use my steps. Okay, so step 1 says I need to look for a GCF for all 4 terms. In this case, because a is equal to 1, there's not one, so I did step 1. Okay. Step 2 says I need to go ahead and look at my last sign. So let's pull this up. And in this case, my last sign is a positive. Now, in order to multiply and get a positive in my binomials, that means that my signs have to be the same. They either have to be both negative or they have to both be positive. Okay? Either one of those, when I multiply them, gives me a positive. All right? So seeing as I know my signs have to be the same, I now go to the next step and look at my first sign. And that first sign tells me that both my signs in my binomial should be positive. Okay. My next step is I want to look at C. C in this case is equal to 8. And I want to look at factors of 8 that are going to add, because my signs are the same, to give me 6. So factors of 8, I have 1 and 8. I have 2 and 4. Okay. Now 1 plus 8 gives me 9. So that's not going to work for me. But 2 plus 4 is equal to 6, so that is going to be the 2 numbers that I want to go ahead and use. I then go ahead and create my 2 binomials. Now in front of each binomial I have my x squared. Remember that x squared comes from multiplying the first 2 terms in each binomial. The 8 is going to come from the last 2 terms in the binomial, which in this case can be 2 or 4. In this case, it doesn't matter where you put them. I'm going to put my 4 there, my 2 there. And I know both my signs must be positive, because that's what I determined at the beginning. And I should have the exact same binomials, maybe in a different order than I started off with. And if I look, I have x plus 2 and x plus 4. Okay, so if I want to, I could go ahead and FOIL this out, and I should get back to here. And it doesn't matter whether the x plus 4 is first or the x plus 2 is first. It doesn't matter. You will end up with the same numbers. Right? So I'm going to go ahead and look at example 1. Example 1, I'm looking at my signs. My last sign is positive. So my signs must be the same, and I'm going to be adding them because they're the same sign. And my first sign is plus, so they're going to be 2 positives. I need to look at factors of 3 that add up to 4 because I'm adding. And I have 3 times 1. 3 plus 1 is equal to 4. So those are going to be my two numbers. I create my two binomials. My variable in this case is x, so x is going to go in the front. And then I put my 1 and my 3 in the back, in whichever order I choose. And both their signs are positive. So I'm going to put my pluses in there. Now you should always check these. That would be step 6. Okay, you should check to see if you get back where you started from. I am not going to check any of these today, but I encourage you to check them, do the FOIL, and see if you get back to where you started. Right? Next example, I have x squared plus 9x plus 8. Again, all pluses. You're going to start to see a pattern here, at least I hope so. My last sign is positive, which means I'm going to either have 2 pluses or 2 negatives, and I'm going to be adding to get my middle 2 terms. And my first sign is plus, so therefore I'm going to have 2 positives. And factors of 8 that add up to 9. So I have 8, I get 1 and 8. I get 2 and 4. 1 and 8 adds up to 9. So that's the combination I want to use. Go ahead and set up my 2 binomials. Put my x's in the front. Put my 8 and my 1 wherever I would like. And put my pluses in. And I should be able to FOIL this and get back where I started. Another thing that is still relevant here that I didn't mention before is you still want to look inside your binomials and make sure you have nothing in common. Okay, because remember, didn't say check for a GCF for all 3 terms. You always should. So in this case, I don't have to worry about it because my A is 1, but please remember that that's still going to be a thing. All right, example 3 starts to get a little bit harder. So again, I have all pluses, so I already know from the first 2 that both of them are going to be plus. I'm going to be adding to get the middle 2 terms. And I need factors of 30 that give me 13. Now it seems like this would be a little hard, but actually this ends up working out really well because 3 times 10 is 30, and 3 plus 10 is 13. So it actually comes up rather quickly. All right. Want to go ahead and set up 2 binomials. My variable is still x. I'm going to put that in the front. I have a 3 and a 10. Doesn't matter where they go. And both my signs are pluses. And again, I should be able to check this, FOIL it, and get back to where I started. All right. Now I got 2 more examples coming up. I would encourage you to try these and then watch me work them out. So go ahead and take a pause. Go ahead and try them both, and then go ahead and hit play. Okay, so the first one I have all pluses, and from my past experience I know that I'm going to have 2 pluses. I'm going to be adding to get the middle term, and this seems kind of weird because there's a 1 at the end. What are factors of 1? The only factors of 1 is 1 times 1, okay? But I need, if I add 1 plus 1, I get 2, which is my middle term. So this is going to work out really nicely, all right? So this one, when I go ahead and set up my 2 binomials, x is my variable. I'm going to put a 1 in the back and 1 in the front. And both of them get pluses. Yes, you can have the same number in each binomial separately. Remember, everything has a 1 anyway. But notice these 2 binomials are exactly the same. All right? Which means you can also write this as like this. All right? And this is something called a perfect square trinomial. And you've heard me mention this before, but we're not going to get too concerned with the name of it right now. But if you do have two identical binomials, you can go ahead and write it like this. All right, let's go ahead and look at the last one. Again, I have all pluses, so I know I'm going to have two pluses. I'm going to be adding to get the middle term. I have a 15, so 15, I have 3 times 5. 3 times 5 is 15. 3 plus 5 is 8. So there's the value I need. I'm going to set up my two binomials. My variable is still x. Nothing's changed. Remember, it could be anything. I could have y's there. I'll make sure you're putting the right one in there. I have a 3 and a 5. I have two pluses. And again, I should be able to check this to see if I got the right values. So go ahead and work on the practice. Ask us any questions that you might have, and I'll see you in the next video.